Hey class, this is your instructor, Miss Birchfield. This lesson is on the rectangular coordinate system and linear equations. Coordinate geometry is a system of geometry where the position of points on the plane is described by using an ordered pair of numbers. So who is Rene Descartes? Well, he was the first mathematician to propose the method of describing the location of points using an ordered pair. He made connection of algebra to geometry. So really before Rene, algebra was not connected until he came up with the ordered points visually to geometry. So, geometry is based on shapes. Of course, in this lesson, we will see the algebra form of a linear equation and its connection to its geometry form, which is a line. And of course, in honor of his work, the coordinates of a point are often referred to as its Cartesian coordinates and the coordinate plane as the Cartesian coordinate plane. All right, so before we get into the lesson, you have to know a few things about the Cartesian coordinate plane. And it says, in coordinate geometry, numbers are placed on the coordinate plane. That's what this is here. It is a two-dimensional surface on which we can plot points, lines, and curves. And the coordinate plane consists of the following. So your horizontal line is called the x-axis. All right, that's the horizontal line that I've labeled here. The vertical line is known as the y-axis. And where they cross is the origin. Of course, that's going to be our starting point. It's going to be the point 0, 0. Okay, and once you cross the two lines, notice that there are 4 different areas that we can name as quadrants. And we can name those quadrants as quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Also, when we're naming quadrants, we use Roman numerals. We do not use the numeral 1 or the numeral 2. We use Roman numerals to name those quadrants. Once the coordinate plane is drawn, then we can find points. All right, well, the coordinates of a point, it is a pair of numbers. Of course, a pair is 2, which we're going to call an ordered pair. And we call it an ordered pair because the order matters. That defines the exact location on a two-dimensional plane. Says that a point on the coordinate plane can be written as an ordered pair, as this example shows here. In this example, the first number, which is the -5, is called the x-coordinate, and then the second number, which is 6, is called the y-coordinate. Just like in alphabet, x comes before y, so in the ordered pair, our x-coordinate, which would be -5, would come before the y-coordinate, which is 6. A point is called an ordered pair because the order matters. And like I was saying, think about, your alphabet. X comes before y, so your x coordinate has to be plotted before your y coordinate. Let me rephrase that. Your x coordinate isn't plotted, but we have to find the x value before we find the y value. And then we're going to always start at the origin when we're plotting points. So when we start at the origin and we talk about our x values going to the right are always going to be positive, And then our y values when we go up are going to be are also positive. So when we think about a point that is in the first quadrant, both of those numbers are going to be positive. Starting at the origin and going to the left will give us a negative number or negative y value, and then going up will give us a positive y value. Starting at the origin, and if we go to the left again, but then let's go down, that's going to give us a negative x and a negative y. And coming back to the origin, going to the right, and then going down would give us a positive x value and then a negative y value. I always think about a number line. To the right are positive values, to the left are negative values. When you're thinking about a vertical line, going up is positive, going down is negative. All right, so just kind of think of it in terms of, if I'm thinking of a number line, going to the right is going to be positive. If I'm going to the left, I'm going to go negative. And then when you're thinking about vertical, up is going to be positive, and then down would be negative. So the first example, we are going to plot these points and label them, and then we're going to name what quadrant or axis they are located. Remember your axis, this is your x-axis, this is your y-axis. So to plot this first point, 2, -1, we're going to start at 0, 0. We're going to go to the right 2, and then we're going to go down -1, and then we're going to place the point, and I'm going to label that point A. And the quadrant is quadrant 4. The next example is the point 0, 5. Well, if I'm here at 0, 0 and my x value is 0, that means I'm not going to move left or right. I'm going to stay where I am. But then for the y value, it's a positive 5, which means I'm going to go up 1, 2, 3, 4, 5. And I'm going to place my point, and I'm going to label it point B. Now notice the point is not in one of the quadrants. It is located on the y-axis. The next example is -3, 5. The x value is -3, which means we're going to go to the left 3. Our y value is a positive 5, which implies that we're going to go up. So we're going to go up 1, 2, 3, 4, 5. And then I'm going to label that as point C, which is in the second quadrant. Point D is the point -2, 0. Our x value is a -2, which means to the left. The y value is 0. Well, since it's 0, we just stay where we are. So our point D, is located on the x-axis. Point E, we've got a fraction. We can have fractions or coordinates as fractions. A -1/2, think of it as like -0.5. -0.5 is located between 0 and -1. So I'm going to go to the left in between 0 and -1, and then -4y, I'm going to go down 1, 2, 3, 4, and I'm just going to estimate my point in between, and I'm going to label that point E, and that is in the third quadrant. And the last example is the point 1.5, 1.5. The x value is positive 1.5. 1.5 is located between 1 and 2. So I'm going to go to the right estimate halfway between 1 and 2, and then I'm going to do the same when I go up. I'm going to go up between 1 and 2, and I'm going to put my point kind of right in here in the middle, just estimate, and I'm going to label it S, which is in the first quadrant. Notice that I used capital letters. When we plot points, we will use capital letters to name them on a coordinate plane. So the purpose of a coordinate plane is to allow us to graph an equation. In this lesson, we're just graphing linear equations. And so we can take the equation of a linear equation, and we can actually see what its picture looks like. So it gives us a picture when we plot it on a coordinate plane. The standard form of a linear equation is looks like this. It's ax plus by equals c, where a, b, and c are real numbers. Okay, so that means we can substitute any number in the place of a, b, or c to form an equation. And it's linear because if you look at your x and your y, notice the exponent, it's an understood 1. And we call this, it's what we call a degree of 1, which implies it's a linear equation. If you start changing exponents, that changes the type of equation that you have. And the graph of a linear equation is a straight line. Now we'll graph in a different lesson, but we're just going to talk about when we graph and we plot points, the points that we graph are what we call the solutions to the equation. So if I have 3 points or ordered pairs and I want to know if they're solutions, what I'm going to do is I'm going to substitute my x value and y value into the equation. So the equation of our line is this equation, and I want to know whether the point 0, -12 is a solution. Okay, so to be a solution, what we need is when we substitute in our values, we need both sides to equal one another. We need a true statement. So I'm going to substitute in place of x. I'm going to place a 0. I'm going to bring my minus sign down, and then I'm going to replace my y value with the -12, and then I'm going to equal it to 12. We can simplify. Of course, 3 times 0 will give us 0. A double negative becomes positive, so 0 plus 12 equals 12, so that's just 12 equals 12. This is true, so our answer is yes, that 0, -12 is a solution. What that means is that this point would be on the line. Next point, we're going to see if it's a solution. We're going to substitute in 1, 9. So in place of x, I'm going to put the 1 there. I'm going to bring my minus sign down, and I'm going to put, instead of y, I'm going to put a 9, equal to 12, and then we're going to simplify. 3 times 1 is 3, minus 9, and then 3 minus 9 is a -6. -6 does not equal 12. This is false. So this is no, that is not a solution. So that means that our point 1, 9 would not be on the line. Our last point that we will test is 2, -6. I'm going to replace x with the 2, bring my minus sign down, and I'm going to replace y with a -6. Notice, and I did not point this out over in the first one, the equation automatically has this minus here. You have to bring it down, and you're substituting in. You've got to put another minus because this point is a negative. So this equation is going to become a double negative. 3 times 2 is 6. We're going to change the double negative to a positive. And then 6 plus 6 is 12. That is true. So that point is a solution. So if I am graphing, or if I had to graph this line, which I'm going to do just to show you, what I would do here is I would come down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I ran out of room. Let me erase this and redo this real quick. Go back. Let's do. All right, so let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I would have a point here. And then we said 2 over 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5, 6. That, let's just estimate. So that would be, this would be our line. So these 2 points here were the solutions. Look at where 1, 9 is, the point 1, 9 here. If I were to plot it, I would go over to the right 1 and go up 1, 2, 3, 4, 5, 6, 7, 8, 9. So notice that it is nowhere on that line. So therefore, it is not a solution. Thank you for listening to this lesson, and have a great day.